Welcome to my video lessons. In this video, I'm going to explain about tune amplifiers. Right? Tune amplifiers. Uh, what is a tune amplifier and types of tune amplifiers and single tune and explanation of the single tune amplifier circuit, double tune amplifier circuit, as well as the Class A tune amplifiers. That means after completion of this video, you will be able to know what is a tune amplifier and what are its types and what is a single tune amplifier, what is a double tune amplifier, its construction and explanation, as well as the Class A tune amplifier and the applications of tune amplifiers. Right. Before starting this session, just I will recall the previous sessions, previous video. Right. In that I discussed about the class B push-pull amplifiers. See, that means power amplifiers based on the conduction angle. The power amplifiers are classified into Class A amplifiers, Class B amplifiers, Class AB, and Class C amplifiers. That means in Class A, the conduction angle is of full cycle, that is 360 degrees, and in Class B, the conduction angle is 180 degrees. In Class AB, the conduction angle is between 180 degrees to 360 degrees, and the Class C, the conduction angle is less than 180 degrees. See, and if here we discussed clearly about the Class B push-pull amplifier circuit. In Class B, the efficiency of Class B amplifier is very high. It is 78.5%, and the output power is also high. That means the losses are less in this Class B amplifier. That means it avoids the even harmonics. In Class B push-pull amplifier, there are two types of Class B circuit push-pull amplifier circuits. In one circuit, there will the circuit is constructed with two transformers and two NPN transistors. In this, the output is good, but what are the drawbacks in this circuit is it needs one input transformer as well as center tapped input transformer as well as the center tapped output transformer. With this, the cost and the size is bulky, and the magnetic effect also, external magnetic field is affected in this amplifier circuit. For that, to avoid this transformers and to avoid the external magnetic field, there is another circuit in Class B, that is complementary symmetry push-pull amplifier circuit. What is a complementary symmetry push-pull amplifier means? The complementary symmetry. The name itself, the circuit consists two complementary transistors, that is one NPN transistor and one PNP transistor, and that means symmetry indicates that the parameters are equal. The features of both the transistors should be, the specification should be same. That is the complementary symmetry push-pull amplifier circuit. So with this, the transformer, the center, no need of center tap transformers in this circuit. Each transistor conducts for one half cycle. One half cycle, and there, in this circuit also there is a transformer, output transformer, but the need of that output transformer is for impedance matching. This is about the Class B push-pull amplifier, and also I discussed about the heat sinks. What is the need of heat sink in the power transistors? Generally, the power dissipation is more in the power transistors. To control that heat, that means to absorb that heat, additional devices are used. Those devices are called heat sinks. Generally, these devices are in metal, black color. Black color, and that is generally this cooling can be done by increasing the surface area with the heat sinks. This is about the heat sink, and I also discussed about the types of heat sinks based on the construction, and that means based on the controlling heat and the device, the power transistor. The heat sinks are classified into push-on type, flat metal, flat tap types. This is about the heat sinks. Okay, now we will enter into our today's session. In today's session, the main topic is tuned power amplifiers. Here, if you read the title, tuned power amplifier, it is a amplifiers right? Amplifier is a circuit, it amplifies the applied input signal. And power amplifier means the amplification is power signal. And tuned power amplifiers, right? Tuned means what is, we all know that what is a tuning. Generally in our daily life we always tune, that means select the particular channel in a radio or a television, whatever it may be, right? This is that means tuning here. What is tuning means selecting the specific frequency, say is called tuning. See that here that is called selectivity. What is a tuned amplifier means an amplifier which amplifies specific frequency or narrow band of frequencies are called tuned amplifiers. Tuned amplifier is a circuit, it amplifies the specific frequency, the particular selected frequency. That amplifiers are called tuned amplifiers. The tuned power amplifiers work at radio frequencies and above. Generally class B and class C amplifiers are used for to design these tuned amplifiers, and the preferred one is the class C amplifier. Here, the efficiency of the tuned amplifier depends on the efficiency of the device as well as the selectivity of the tuned circuit. What is selectivity means? Tuning a particular frequency is called selectivity. The efficiency also depends on the efficiency of the device as well as the selectivity. How much exactly we selected the frequency. Right. The power dissipation is low, so the efficiency of these are very high efficiency amplifier circuits. It can deliver more power to the load. Output power is more. The classification of the tuned amplifiers are mainly classified into three types: single tune amplifiers, double tune amplifiers, and stagger tune amplifiers. See, if you what is single tune means tune amplifier, and generally in this tune amplifier, the main circuit is a tuning circuit that we can call tank circuit. What is a tank circuit? A parallel connection of L and C elements is called a tank circuit or a tune circuit. So, in single tune amplifiers, the tuning circuit is a single circuit, that means one single tuned circuit is used, whereas in the double tune two tune circuit, this double tune amplifier consists two tuning circuits. And the next one is the stagger tune amplifier. And what is stagger means? In double tune, for more bandwidth, and the tuning is the tune circuits are required tune circuits are two, that will be avoided in the stagger tune amplifiers by coupling of single tuned. This is about the classification of the tune amplifiers, right? First one is the single tune amplifiers. We'll discuss the construction and the working operation of the single tune amplifier. So this is a circuit diagram of a single tune amplifier. If you observe this is common emitter circuit. R1 and R2 are the voltage dividing biasing resistors, and this is the capacitor, the input capacitor. This is the applied input signal Vs, source voltage. Re and Ce, emitter resistor and emitter capacitor for thermal stability. And here the tune L and C components are connected in parallel and connected at the collector of the transistor. See, this is the second coil, only inductive coil is there, and the load is across this. This is the construction of the single tune circuit, right? R1 and RT, RER for biasing, CE for bypassing, is a bypass capacitor. L and C are forming the load, that means tuned circuit. This impedance depends in the input signal frequency. This tuned circuit impedance depends on the input signal frequency. This LC circuit is also called tuned circuits. So capacitors are coupling capacitors. This is the construction of the circuit. Here in the circuit, the tuned circuit is LNC. The main circuit operation is tuning. What is tuning? Selecting the particular frequency and amplifying that signal frequency. So to select that required frequency, the values of LNC, inductance and capacitance are selected such that its resonant frequency is equal to the frequency to be amplified. For a tuning circuit, there will be a resonant frequency. What is resonant frequency means? At resonant frequency, XL is equals to XC. We know that XL is equals to XC. The reactance of inductance is equals to the reactance of the capacitor at resonant frequency. So, and that means at the what is at its resonant frequency is equals to the frequency to be amplified. That the value that means, suppose we need to select the particular frequency. This frequency should be equal to the resonant frequency of the tank circuit. So by varying the value of C, by varying the value of capacitor, you see here in this tank circuit, C is a variable capacitor. By varying the value of the capacitance value, we will select the required frequency. That means the circuit will be at a resonant frequency. That resonant frequency is equals to the whatever we required selective frequency. Operation of the circuit. When the input signal frequency varies, the tuned circuit impedance connected in the collector circuit also varies. Based on the applied input signal, the impedance of the tuned circuit varies. At resonant frequency, the LC tuned circuits offers high impedance. The input is varying with when the input signal is varying means the impedance is also varying. At resonant frequency, the circuit offers high impedance, and at high impedance means the output is high. That is, maximum amplification is achieved. At resonant frequency, the impedance will be high. Impedance will be high. That means the output is high. Output is high. Output is high means the applied signal is amplified. For other than resonant frequency, tuned circuit impedance is low and output is also low. That means in the single tune amplifiers, the single tune amplifier, that means common emitter circuit with a single tune circuit. That means one LC tank circuit is connected at the collector. In that, C is a variable capacitor. By varying the capacitance, we can select the required frequency. At resonant frequency, this LC circuit offers a high impedance. High impedance means the output is high. Output is high means for the given input, that means for the selected input, the signal is amplified. Signal is amplified. Other than the selected frequency, required frequencies, the output is low. That means why the output is low for the remaining frequencies means this resonant circuit offers high impedance only at the resonant frequency. For other frequencies, the impedance is low. That means the output is also low. This is about the single tune amplifier circuit. See, by designing this tuned circuit properly, once the desired range of frequencies can be selected and other signals can be rejected. Tuned amplifier circuit selects only the required frequency. The remaining signals are rejected. Here the selectivity. What is selectivity? Tuning the required frequency is called selectivity. This selectivity is equals to, it is the ratio of resonant frequency to the bandwidth. Here FR is the resonant frequency. What is resonant frequency at which XL is equals to XC and divided by the bandwidth. Selectivity is the ratio of resonant frequency to the bandwidth. See, this is the frequency response of tuned amplifier circuit. If you observe this frequency response at resonant frequency at FR, the tank circuit impedance is high, output is high. That means we will get the maximum gain. Maximum gain. The single tune amplifier circuit at resonant frequency, the circuit offers high impedance. At high impedance, the output is high. That means the circuit offers high gain at resonant frequency. The maximum will be at resonant frequency. The gain will be decreases before and after other than the resonant frequencies, below the resonant and above the resonant frequencies. This is a narrow band of frequency. Narrow band of frequency. This is about the single tune amplifier circuit. And what are the limitations of single tune amplifier circuit means? See, the limitation is potential instability. What is potential instability means we'll discuss. See here, for highly selective, they are required to be highly selective. The tune amplifiers are needed for highly selective, high selectivity. For high selectivity, the Q should be high. The Q factor should be high. For high selectivity, the Q should be high. Q is high means gain is high. Q factor is high means the gain of the circuit is high, but the bandwidth is reduced. High Q tune circuit offer bandwidth is limited. That means reduced bandwidth may not amplify equally the complete band of signals. Complete band of signals and results in poor reproduction. Poor reproduction. The poor reproduction, that means the output is not exactly same as the input. This is due to the narrow band. This is due to the reduced bandwidth. Why this circuit has reduced bandwidth means due to high Q. Why this high Q factor is required means for high selectivity, definitely the Q should be high. Because of this high Q, bandwidth is reducing. This reduced bandwidth is unable to, may not be amplify equally the complete band of signals. Therefore, there is a poor reproduction of the signal. This poor reproduction is called potential instability. Potential instability. Right? This is the limitation of the single tune amplifier circuit. This drawback is this will be avoided in the double tune amplifier. Double tune amplifiers. See, double tune. The name itself, it is saying that it has two tune circuits. Two tune circuits. The problem of potential instability with a single tune amplifier is overcome in double tune amplifier. Double tune amplifier. It consists of two inductively coupled tune circuits, L1C1, one inductive tune circuit, and L2C2 is another inductive circuit. Right? This is the double tune circuit. See, this is first tune circuit is connected at the collector of the transistor, and there will be a mutual inductance between the two tune circuits, and the output is taken at the second another tune circuit, that is L2 and C2. The remaining circuit is similar to the single tune circuit. R1 and R2 are here for biasing. C is for bypassing capacitor. C is here input coupling capacitor. Whatever may be the signal that is applied at the Vs. This is the construction of the double tuned amplifier circuit. Now, what is the difference between that means? It has two tuned circuits, L1C1 and L2C2. A change in the coupling of the two tuned circuits results in the change in the shape of the frequency response curve. So here the frequency responses depends on the two tuned circuits, and that too the coupling and the how the second circuit is means with the mutual inductance. By proper adjustment of the coupling between the two coils of the tuned circuits, the required results will be obtained. That means coupling should be done properly to get the required output. You will see the circuit operation of the double tune amplifier. The high frequency signal to be amplified is applied to the input terminal of the amplifier. The frequency of this tuned circuit connected in the collector circuit is made equal to signal frequency by varying the value of C1. So whatever we need to select that frequency will be selected by varying the variable capacitor C1 value in the first tuned circuit L1 C1 tank circuit that is collected at the collector circuit. By varying the C1 value, the resonant frequency will be equal to the selected frequency. Now, the tuned circuit L1 C1 offers high impedance at resonant. This tank circuit offers high impedance to the selected signal frequency, and large output is developed across it. That means at L1 C1 the output is larger at resonant frequency. This output from L1 C1 is transferred to the second tuned circuit through mutual induction. This we already know the what is mutual induction. Right. See, what is mutual inductance? What is mutual inductance? When the EMF is induced in the secondary coil, the EMF induced in the secondary coil is due to the varying magnetic field of the primary coil. How the EMF is induced means when the in the first coil, when the magnetic field is inducing in the primary coil means there will be an induced EMF in the secondary coil. That is called mutual inductance. See, this is the first coil with the varying magnetic field. There will be a magnetic EMF induced in the second coil, flux induced. First tank circuit and second tank circuit, there will be a coupling between these two circuits, and the coupling coefficient depends on the distance between these two tank circuits. See here, when the coils are spaced apart, if the distance between the tank circuit 1 and 2, that means the flux linkage of primary coil L1 and flux of secondary coil L2, the distance is spaced apart. At this condition, the coils are said to have loose coupling. If the distance between the two tank circuits is more, that coupling is called loose coupling. Loose coupling, that means the coupling is not strong. With this loose coupling, the resistance reflected from the secondary coil at this condition is small. So the resistance of secondary circuit is small and the resonance curve will be short and the circuit Q is high. For the loose coupling, the frequency response will be like this due to the low resistance. But in the loose coupling, the resistance of the secondary coil is small. With this, the high Q is high, the gain will be maximum at resonant frequency. And if the distance between the two coils are close together, that means it is called tight coupling. If the primary and secondary coil are close together, it is called tight coupling. Under tight coupling, the reflected resistance will be large. That means the resistance of the L2 is large and the circuit Q is lower. Circuit Q is lower. Circuit Q is lower and the two positions of the gain maxima. See, when the circuit Q is lower, the frequency response is like this. This is the frequency response for tight coupling. That means now gain is maximum at two frequencies. One is above the resonant frequency and one is below the resonant frequency. At resonant, the gain is minimum. And in tight coupling, what is tight coupling? In the tight coupling, the two coils are close together. That coupling is called tight coupling. In this tight coupling, the resistance is high. In the second L2 coil, the resistance is high. With this high resistance, the Q is less, the Q is low. With this, it is will get gain will be maximum at two levels. Gain will be maximum at two levels. Two positions of gain maxima, one above and the other below the resonant frequency are obtained in the double tune circuits. You see here that poor reproduction is, and the drawback of single tune amplifier is poor reproduction because of high Q. But here the Q is lower. That means the bandwidth is more in this double tune amplifiers. The frequency response of the circuit depends on the coefficient of coupling. The frequency response is depending on the coupling coefficient. Because of coupling of coils L1C1, a portion of load resistance is coupled into the tank circuit L1C1 and affects it in exactly the same manner as to a resistor load being inserted in series with the coil L1. So, see, in this, the coupling is depending on the coefficient of coupling and the bandwidth. Bandwidth is increasing with increasing degree of coupling. This double tune circuit bandwidth is more compared to the single tune circuit. This bandwidth, how much bandwidth is increasing means it is depending on the degree of coupling. The bandwidth is equals to K into FR. K into FR, where K is the coupling coefficient and FR is the resonant frequency. Resonant frequency. In a double tune amplifier circuit, bandwidth is depending on the coupling coefficient as well as the resonant frequency. So if the coupling coefficient is increasing means bandwidth also increases. This is about the double tune amplifier circuit. And the next one is Class C tune amplifier. Class tune amplifier circuit. This tune amplifier has very high efficiency because they are operated in class C and that but in class C the distortion is high. This can be eliminated by using tune circuit as the load in the collector. Generally in class C the efficiency high but the distortion is more. This distortion is reduced by placing a tune circuit in the collector. Right? See, this is the class C tune amplifier circuit. This is the class C amplifier and the tune circuit is placed at the collector of the transistor. The output is taken. We know that the conduction angle of class C is of less than 180 degrees. Class C tune amplifier is a Class C power amplifier consists of a parallel tank circuit. How this Class C tune amplifier is constructed means, for a Class C power amplifier circuit, there will be a parallel tank circuit at the collector. The collector current flows for less than half a cycle. The conduction angle of Class C amplifier is less than 180 degrees. That is the reason the collector current flows for less than half a cycle. This parallel resonant circuit filters the pulses of collector current and produces a sine wave of output voltage. The output of this tune circuit is sine wave. It filters the pulses of collector current and produces a pure sine wave. The maximum efficiency of it is 100%. When the AC input voltage is applied at the base of the transistor, an amplified output voltage appears at the collector of the transistor. Up to this we know, right? This amplified and inverted signal is capacitively coupled to the load resistance. At the collector there will be a tank circuit. This amplified signal and this output at the collector is amplified and inverted signal. It is capacitively coupled to the load resistance. The output is maximum at resonant frequency. It offers high impedance at resonant frequency. So the output is maximum at resonant frequency. Generally, the Class C tune amplifier is for narrowband amplification, narrowband of frequencies. To amplify a narrowband of frequencies, this tuned Class C amplifier is preferred. The input and output waveforms are of Class C tuned amplifier. See, this is the input. This is the collector current. The conduction is less than 180 degrees. This is the collector voltage. And the amplified output is pure sine wave. Pure sine wave. Applications of tune amplifiers. See, what are the applications where we can use the tune amplifiers? Means we already generally will use these tune amplifiers for tuning the selective frequency in mm, televisions and radios, right? And the circuits, these tune amplifiers are used of video signal amplification in the wideband range. In the wideband range, the circuit of video signal amplification in the wideband range use these amplifiers. For video signal amplification, these tuned amplifiers are used in the wideband range. As well as for wireless long distance communications, these amplifiers are used due to high gains. In wireless also, that is for long distance communication, these amplifiers are used for due to high gains. At the receiving stage, these are used as radio frequency amplifiers. The main application of tune amplifier is radio frequency or amplifiers. Even the devices used for communications that work on radio frequencies prefer these amplifiers. Generally, tune amplifiers are used as radio frequency amplifiers. These are used for wireless long distance communications as well as video signal amplification. These are the applications of tune amplifiers. Right? The brief summary of today's session. We discussed about single tune amplifier. That means it has one tune circuit at resonant frequency. The impedance should be high. Because of high impedance, the output is high. That means maximum gain will be gets at resonant frequency. But there is a drawback. There is a poor reproduction of the signal that will be avoided in the double tune amplifier with two tune circuits. That means this bandwidth is increased with double tune circuits. That means with a mutual inductance. The Q will be low in double tune amplifier circuit and bandwidth will be high. And also we discussed about the class A tune amplifiers. What are the questions we can expect from this topic? Means in long answers we can expect draw and explain the single tune amplifier with waveforms, and also draw and explain double tune amplifier circuit with waveforms, as well as see, draw and explain single tune amplifier means you need to draw the circuit of single tune amplifier circuit and explanation with frequency response. In single tune amplifier circuit, the gain will be maximum at resonant frequency, and it will be less decreased below and above the resonant frequencies. And what are the limitations of this single tuned amplifier we can expect in short answers. What is the limitation of single tune amplifier? Means the signal poor reproduction. This is because of high Q. Why this Q factor should be high? Means for this high selectivity, the Q should be high. This high Q gives the high gain but less bandwidth. This reduced bandwidth, that means narrow band of frequencies. This reduced bandwidth may not reproduce the original signal for all the frequencies. That is the reason there is a poor reproduction in the signal. That is the drawback of the single tune amplifier. That means you can expect the question from for long answers in the long answer as well as the short answers. Right, this and the next we can expect from the second topic, that is double tune amplifier. You can expect the long answer, draw and explain the double tune amplifier. So here draw the circuit and explain the circuit, and and sometimes there will be a short answer of explain the frequency response of double tune amplifier circuit. That means in the double tune amplifier circuit, the response the frequency response, that means it depends on the coupling coefficient. If both the two tune circuits are separated apart. That means the distance between the pure tuned circuits is more, means the induced EMF in the secondary coil is less. Secondary coil is less. Generally, that is called loose coupling. Loose coupling. So what is with this loose coupling, the inductance will be less. The EMF induced in the secondary coil is less, and the here it offers high small resistance. That means Q is high. The gain will be maximum at resonant frequency, and it decreases below and above the resonant frequencies. And come to this next one is tight coupling. In the tight coupling, what is happen? What is tight coupling means? The two coils are close together. Close together. With this the tight coupling, the resistance is small. The resistance offered is high. That means Q is low. With low Q, the gain will be maximum at 2 points. At 2 points, that means above the resonant frequency and below the resonant frequency, the gain will be maximum. And after that, the gain is minimum at resonant frequency in the tight coupling. Right? In a tight coupling. This is about the frequency response of the double tune amplifiers. That means from double tune amplifier circuit, you can expect and explain the double tune amplifier circuit and explain the free. And in the you can expect another question: what is the frequency response of double tune amplifier circuit? Right. The next topic is Class C tune amplifier. Draw and explain the Class C tune amplifier circuit, and you can also expect the draw the input and output waveforms of Class C tune amplifier in short answers. In the short answers, right? And we can also you can also expect list the applications of tune amplifiers in the short answers. What is a tune amplifier? As well as classify the tune amplifiers. These all are the that means in this topic you can expect long answers as well as short answers. Short answers. See, with this tune amplifiers, our third unit is finished. That means in the third unit we discussed the third unit is power amplifiers and tune amplifiers. We discussed about what is a power amplifier, classification, and the difference between voltage amplifiers and power amplifiers, as well as classification of power amplifiers. Power amplifiers are classified based on the conduction angle as well as based on the frequency range. And also we discussed about we discussed Class A amplifier, Class B amplifier, all this. And in today's session we discussed about the tune amplifiers. Tune amplifiers. With this, this third unit is finished. In the next session, I'm going to explain about the fourth unit, that is oscillators. And that means in the till now we discussed about amplifiers. Amplifiers, what is an amplifier? Means it is a circuit, it amplifies the signal. Based on the signal amplification, these are classified into small signal and large signal. That means voltage amplifiers and power amplifiers. Those two we discussed till now. In the next session we'll discuss about the oscillators. See, oscillators, that means we know the feedback is of two types: positive feedback and negative feedback. Generally in the amplifiers, the applied feedback is negative feedback. In the next session we'll discuss about the positive feedback, that means oscillator circuits. Right? Okay, with I'm going to end my session. Thank you.